Okay, we had the midterm examination last week, and which covers from chapter 1 to chapter 5. And the first part was asking you to check whether the given statement is true or not. So, in this, for the first problem, actually, we cannot say, with this condition, we cannot say this limit does always exist because we have a counterexample as 0 over 0. And this limit exists and this limit exists, but this limit may not exist. Okay, and the others are true and the others are true, but this one too. And even though the integral from a to b f of x dx is equal to 0, we cannot tell f of x must be 0 because we have also a counterexample such as f of x is equal to x on minus 1 to 1. This is not a 0 function, but still integral x dx from minus 1 to 1 is 0. And this is true. And here, this catenary curve can be represented with the equation y is equal to c plus a hyperbolic cosine x over a instead of sine. So this is the right statement, which I gave an emphasis. And and the very last four are false. Because here the c prime of x was defined as a marginal cost function, but that marginal cost function does not represent the cost per unit. The cost per unit is the c over x, total cost divided by the number of the product. That will give us the cost per unit. These may not be same. Okay, and here, if f of x is continuous on the interval, and then there exists a sigma, the psi, such that integral a to b f of x dx is equal to f of psi times b minus a. That's the one theorem. And the 11th one was if f is a continuous function on AB, then f of x is equal to integral f of t dt from a to x is continuous on AB, and the capital F of x is differentiable. That's the right statement. And the last one, let f be a continuous function on AB. Suppose that f is continuous on AB, and that f prime of f prime is equal to f on AB, then integral f of x dx from a to b is equal to f of b minus f of AB. Now, we don't need the absolute value here. So most of you did okay on those. And others are just state some of the concept and definitions and terminologies. And most of you did well on this. And the next one was the one problem from your exercise and homework problems. Discuss the geometric and physical interpretation of f prime of x here. So f prime of x, this means in geometrically the slope of a tangent line to a point. And physical interpretation can be given as average velocity. Then average velocity can be written as the ratio between the distance traveled and the time elapsed. Those are the meaning of some meaning of f prime of x. And also I gave you to read the mathematical the way of express the mathematical terminology in intuition and in mathematically. And I just asked you to rewrite what you know about on those concepts. And most of you did okay on that too. And next was Newton's method. You should know. You should know this, and you know how actually to manipulate this process by sage applet, sage cells that I have made. And also, yeah, this theorem, this problem asks you to just write what you know about the number E, which we spent pretty much of time to talk about. Okay, there are lots of things that you can write. So I gave, this is a 3-point verse problem, and I gave 1 point on this. If you define the e to the x as f of x, then, and write the property of this, then you got 1 point. And also, if you found the f prime of the derivative of e to the x is equal to e to the x, which means the rate of change of any exponential function is proportional to the function itself. That cost 1 point. And also, e is the number such that ln of e is equal to 1. That also counted as a 1 point. So actually it's a 3-point problem. And others are, yeah, how do you draw the graph of such a function, ellipse. This can be done by elliptic function and graphing, which I made the applet. And also, I gave the Sage command for the implicit plotting. And so all you had to do is just copy those commands to write it. And following, and also, yeah, I wanna you to find where these two equations meet. And so all you have to do is just define a function f of x as a subtraction of those. And then you just draw it, then you will see those two equations, the functions meet at this point, which is about has at least one real root. Yeah, so that's what I want you to find. And what else? Here at 4.49. And the others, yeah, just find f of 0 when you have a function f of x like this, which make this function continuous. And you just define f of 0 to make it same. So all you have to do is just find the limit of it and just then define that value as the value of the function f at x is equal to 0. And next, and we plot the graph of the derivative of f of x using the Sage. So all you have to do is just write this function in a way like this. Then you will have a graph like this. And from this graph you can expect this. You can then this is the graph of the derivative of this. So from this graph you can expect when the original function increase and decrease, and when it has critical values or maximum values and minimum values from here, because the function increasing when it is positive, when it is decreasing when the value of derivative is negative. So here you can see where it has increasing period and decreasing period and increasing period and decreasing period. So you can find it. And also this gives us the critical value, which will give us maximum or minimum. So we can find the 3 critical values from there. So from there, you can find the maximum and minimum values. So from those are the things that you can deduce from the given informations. And find the limit of the functions. Yeah, this is just a very simple computation. And find the limit using the natural log and L'Hopital's rule. Yeah, so you define the y function like this, and then use ln of y to find the limit, and then use that limit to deduce the limit of y when x goes to 0. And yeah, find the tangent line at this point of this parametric equation. All you have to do is find just dy dx at dy over dx at t is equal to pi over 2. That is this. So, and then you have a velocity and the speed like this. And use the derivatives, use the differential to find the approximation of square root of 98. So all you had to do was, since the square root of 98 can be written as f of 100 plus delta x, which is can be approximated by f of 100 plus df at x is equal to 100, which is this by the differential. So it's 9.9. And also this function, this closed cylindrical can, this is kind of optimization problem. And so all you have to do is find the formula for the volume and then use the derivative to find the critical point to minimize or maximize the conditions. And this graph can be drawn by this. So we can easily expect the solutions are here, which is about between 4 and 5. And here, this is also one story problem. Then the question was explained why this company want to hire more workers. From this observation, the owner can easily expect that if they hire more people, then they will have a better productivity that guarantees the high profit. So they can easily make the business decision based on this differential calculus. And also evaluate the area covered by those two functions, actually this area, which can be found in this equation. So if you integrate from, you can easily find the point that those 2 points meet, and integrate from -1 to 2 of the upper one to lower one, y minus y square minus 2 dy gives us 9 over 2 as the answer. And if this is an antiderivative of f of x, then what is this? And I gave us some hint. So all you had to do was just use this hint to find the integral of f of x, f prime of x dx, which can be written as the integral u dx, which is this. Then you just resubstitute f of x in here, which so this, and this is the problem that one of you actually showed in. So all you have to, for these changes, all you have to find is integral n of t dt from 0 to 10, which is this. So what you left is the initial value, initial number of b's plus this increased number of b's, which makes 2,430 b's left after 10 weeks. And the last part of 4 problems, and prove and explain, and that gives you and show this limit. The limit of this is -9. So use the epsilon delta argument to prove it, which you have done it. And so all you have to do is a size computation, and then use this size computation to find the proper delta. And here, if you, so I wanted you find this the derivative of hyperbolic secant x, and this given informations can be easily used to draw the given equations. And then if f is a continuous function, then f of x is continuous and is differentiable, and f prime of x is equal to f of t. This is actually one of the problems in the textbook exercise, and this was made as a box problem, so you can you can go through it to check the reading ability of mathematical writing. And the last one was the find the integral from of ln of x over x dx from 1 to e, which can be easily found. And also you can draw the graph without much difficulties. And I also gave you some extra point for your participation. And also, I gave you the SAGE command that you can use in the midterm examination. And also, I gave the whole table and the graphs that can help you to deal with the given problems. But also, I gave you the newly developed the graph, which you can easily manipulate it, and also, you can find the animation of these given functions without much difficulties. You can even make you can draw the graph and animations with this, and also you can add it in your homework as an animation. So it will be most easy way to do your homeworks. So from now on, you will be asked to add such an animation in your homeworks while you are doing it. Okay, and also, and this parametric plot. So actually, I made several of those. Copy, and on the SAGE cell here. Then this is a parametric plot. You can see how this heart can be changed as the parameter ABC been changed. And also you can delete the grid, and you can see the changes of this graph as time t changes from 1 to 20. You see? So you can draw a most beautiful heart that as you wish here. And then you can send it to your lover. Okay. Anyway, and this is your tentative standing. This is a tentative standing, and I made some collections. My teaching assistant gave the point on online attendance after 7th weeks, but I added your work, your attendance up to the 8th weeks. So most of you did okay on it, and that made minor changes on your total point. And this is actually this is your final exam scores here. If you find any misprinting, then let me know. And these are the real point with the 100-point ratio, with the percentage which was assigned for each of the categories as was noted in the syllabus. So, but it still is tentative because we didn't have a final examination, and also I had to check your April PBL report. This is a March PBL, but with the April PBL that it will be changed. So with within 1 or 2 weeks, your final standing up to 10th week will be fixed. Then. I tried to give the best score, best grade to you, but I think you have still more room to improve yourself. And there are a lot more things. Thus, I have uploaded some of those used, and also here this also is interesting. Copy. Here, this shows what the Riemann sum. And this is a new applet with right rules. If you change it, then the graph should change. And if you this shows what? This shows the graph. If you have the 10 boxes, then this summation gives you what? The numbers, and also this shows if you have one box to gain the area of this area, then these are the errors when you have the number of these boxes. When you have a small segment, when you have a more segment of rectangles to approximate the area under the graph, then these numbers shows the error between the real area and the approximate area are decreased. So probably after about 20 steps, you will have almost the same area of the area underneath the given functions. And those things can be also saved here and then can be used here to explain more. These are the things that we have developed for the first time, so you are the first beneficiary on those. And Mr. Jung-Seung Chan, I made the changes on your grade. I found your previous online attendance point was 21, but now after I checked it this morning, I made it to the 25. And also there are actually yes, there were many suggestions for the last half of the semester. So I gave some answers on your comment here, so you may take a look on those. So what I found was you wanted to have more difficult problems to distinct the best student. So I will keep those in mind. But as you see, the exam scores is in the very normal distribution, which make a perfect 변별력 on your performance. So actually, it worked very well for the midterm examination. And what else? Here, this is the web page that I have made. Here you will find all those informations that we have developed over this semester, and from the beginning of the class, and also from chapter 1 to chapter 5. There you will be able to find all the single cells to compute the problems that you have covered, and also and up to chapter 5, and also I added the single cells which I have revised on chapter 6 and some on 7. So I will keep adding all those. So for example, we're going to see the chapter 1, example 6, then you may copy. Just to practice those in your Sage, the Chrome or Firefox. Here, you're going to see how we find the area between these two curves. And in chapter 7, and also the rotation of these with respect to x-axis or y-axis and those things. Those are the things that you're going to learn today. So before we start, if you have any questions, then I'll be happy to answer for that. So I have uploaded some of the answers on your questions. So you may just go through what I have given to you. Here to Mr. Jogonu and Mr. Kim Dae-hwan and many others in here. And also, as soon as we cover chapter 6 and 7, and you will have a chance to solve and present your solutions on each of chapters and sections. So I have assigned some of the work for you, and so please do so. And also I'm asking some candidates and volunteers to solve the problems in each section. So you may add your names in Q&A. Okay? Okay, I think that will be quite enough. And just one other thing. Here. For example, we are not the only one who's doing this. Here, this is which school? Penn State University. Here, if you click this, then this also shows the area and circumscribed. Then in order to find the area of the circle, we can approximate the number of the polygon, the size, and then this area is getting closer and closer from the here, and zoom in and zoom out. So from here, if you then it goes getting closer and closer, so this converges to the real area of a circle that can be found by the circumscribed polygons with those inside and outside. If you increase the number of those sides, then like you see that area of outside and area of inside will converge to the real area of a circle. And so there are many things like this to make a better understanding of it. And here, integral calculus, and these are the things, disk method and Washer method and shell method. Those are the things that we're going to learn from chapter 6, and these are the Java tools to understand it. But we have done most of these things in Sage, which is more easy to make and easy to use. So I think you are in very good shape. This is a web address that you can use. Okay, any question before we start chapter 6?